Okay, so let's move on to our next presentation. Like I said, Eugene is going to be presenting for us, talking about Node.js also. Okay, so let me welcome him to the screen. Welcome.
Hello, do you hear me well?
Yes, perfect. All right, I know you're going to be sharing your screen. There you go. All over to you.
Okay. Yeah, so hi everyone. My name is Eugene Fidelin, and I'm working as a front-end architect at Marktplaats, which is now part of Adevinta. And my topic for today is to tell a story about our way towards a better micro frontends by using the Node.js BFFs. So before I start deep diving, let me give you some understanding what Marktplaats is. So basically, it's the biggest, the largest trading platform in the Netherlands, with over 8 million unique visitors monthly and almost 19 million live ads. So if you live in Netherlands for at least half a year, you might use this platform. And you imagine that whatever feature we build, it impacts a huge amount of users. So in my topic, I mentioned a couple of definitions. So let's maybe define what do they mean. So I'll start with the micro frontend. So this is quite a broad term, and I like this statement. So micro frontend is an architectural style where independently deliverable frontend applications are composed into a greater whole. So in my opinion, the key statements here are independently deliverable and composed. I think this is what makes a difference with this approach. So if you look at this diagram, it might be a bit clear. What does it mean? So you have like 3 micro frontends. They might have their own source control. They should have their own build and test pipeline. They run independently on production, and then somehow they are composed into like a bigger application on the front end. On the production. And there are multiple ways how you can compose micro frontends. So the first approach with infrastructure, where you have an HTTP server in the front of your applications, it's probably the easiest one, and you can think maybe it's a bit of old-fashioned way. In this case, the minimal delivery is the page. Another approach is to do composition on the build time. So imagine you have a standalone application. We can talk about React application like header or footer, which is reused across all your platform. And then you can deliver it as an NPM package and use it in your front-end application, compose it, build time, deploy to production. And maybe the most modern one, the latest addition to those, is the runtime composition. So in this case, you have a controller application which runs in the browser and or on the server, and then it selects on its own which script application to load and to render. So at the moment, we use a combination of infrastructure and build time and composition. Our journey started like in 2019. So at that time, there were only 2 available options, like production ready. But at the moment, we are investigating the way how we can do the runtime composition as well. So the next thing that I mentioned is the BFF. So BFF stands for backend for frontend. And it's also an architectural pattern where each front-end application has a corresponding backend whose purpose is solely to serve needs for that front-end. So again, if you look at the diagram, it might be much easier to get the idea. So you have the front-end, it might be even a micro front-end. It only talks to its own BFF, and then BFF, which runs on the server, is allowed to talk to multiple downstream services. And of course, the downstream services can be shared across multiple BFFs. And this is the approach that we use as well. So why do I think that micro frontends and BFFs are the best friends? Well, first of all, the BFF allows you to have a different way of authentication, authorization users on the client side and whenever you talk to downstream APIs. So in our case, we use cookie authentication on the client side, but when we talk to our APIs, we use token-based. And this is handled by BFFs. You can also have much flexible A/B experiment setup because you have a choice how you want to run the experiment on the server, on the client, and if you run it on the server, you cannot even ship the code for that experiment that is not active to the client. And maybe the most important feature of the BFF, that you can do data fetching that is very highly tailored for the needs of your specific application. So our BFFs, in general, we run multiple calls to downstream APIs, then we massage the data.
You've muted yourself. It might be, have your headphones gone dead? It wouldn't be a proper conference if we didn't have some little glitch somewhere.
Oh, sorry. Yeah, my headphones are dead, but I hope you still hear me well. Yeah, sorry for that. And yeah, so yeah, as I mentioned, this data fetching and aggregation is maybe the most important feature of that BFF offers, because you can only expose the data that is needed for your client-side application. And the last but not the least is the server-side rendering on demand. So because you run a piece of code on the server, you can server-side render your React application whenever needed. And for example, we do it for the piece of UI that is either important for the SEO or maybe critical for the user experience. So where we started our journey 3 years ago, we had like 3 huge monolithic front ends built on the server with Java, on the client side with Backbone. They were really tightly coupled with the backend services. There were no clear ownership of this front-end code base, because it was shared across multiple teams, and also both backend developers and front-end developers were committing to the same code base. That leads to the thing that their business logic was leaking in the view layer. We had no support for multiple tenants and languages. At that time, it was the platform that only serves for Netherlands and only in Dutch language. We have very fragile builds because we heavily rely on end-to-end tests. And that basically caused that sometimes our time to market for features was extremely long. So I remember times where we waited for weeks to have a green build for the front end. And next to that, we also had quite old and legacy JavaScript stack. And as I mentioned, on the server, we even have Java with JavaScript server pages on top, and no one liked that, which leads to a very low developer happiness. It was quite hard to hire new people that would like to work on that. So where we are now, at the moment, we have more than 25 small and loosely coupled, but highly aligned backend for frontends. Each backend for frontend is owned by a specific team, and it is tailored to a specific step of the user journey, so it's quite small and isolated. Our downstream APIs, they contain the business logic, and their responsibilities to prevent the leaking that business logic to the BFF layer. We also support multiple tenants and languages. We managed to make our builds more stable because we now rely more on integration and unit tests, and we write much, much less end-to-end tests. That helped us to achieve shorter time to market. And what helped here is that we are also able to use modern JavaScript, TypeScript, and frameworks both on the server and on the client side of the BFF. And yeah, I hope our developers have much higher happiness and productivity at the moment. So what kind of architectural changes we did during this migration? So we decided to move to this micro front-end architecture because we think it might solve like the multiple problems, and one of them is it will allow us to split these scary monoliths into like a smaller independent applications that we can test, deploy, and maintain like in isolation. And this was the main goal, to help our independent cross-functional teams to deliver quicker and be more autonomous. So if you look on the left side, In this red box, you can see that we have monolithic web frontend and monolithic app frontend, and they were split into a set of independent web BFFs and app BFFs that are talking to the same set of downstream APIs, and they fetch data from some backend services. So you might notice that we also use this backend for frontend pattern also to build app BFFs that serves data for our native app applications, but this is outside of the scope of this presentation, so we will focus only on web BFFs. And this allows us to split the business logic and view logic. So the view logic now lives solely in BFFs, and the business logic lives only in APIs level. So if we zoom into one instance of the web BFF, so how does it look like? The heart of it is the Node.js application, which is built with Express.js, which accepts requests through a chain of middlewares. It is able to make a request to downstream APIs through the API client, and it's also able to do HTML rendering for our React on the backend, and it's also responsible for serving the web application that runs in the browser through the CDN. And as you might see, we use the cloud router, which is traffic in our case, and this is the way how we do this infrastructure composition. So traffic is responsible for routing incoming requests to a specific BFF that is responsible for serving a specific page on our website. So how does it look from a developer perspective? So maybe one of the greatest features that you can run each BFF in isolation independently on your local machine, and it doesn't depend on any other service. So literally, you only need a Node.js on your machine. If you need data, and for most BFFs you need data, you can consume API from any other environment. So you can connect from your local machine to environment on demo, on integration, on someone's dev tenant, we call it, or even you can run it against the API that runs on your local machine. And because the front-end developers are now writing both server-side and client-side code, they're able to choose the best possible approach to implement a specific feature. So you're not limited anymore to do everything only in the browser. You can decide on your own what would be the best way. Because the BFF only gets data from the API, the Swagger, which is provided by APIs, is our contract between BFF and API. So this is a very important piece of communication between front-enders and back-enders, because this is the way how we say, okay, what do we need from API and what API can provide to us. Next to that, inside the BFF, we use TypeScript, and the TypeScript allows us to do even more because we share the types between server and the client application. We're able to track how the data flows. So we're able to understand like what the shape of data do we receive from API, how do we manipulate with this data on the server, and what data is exposed in what shape to the client-side application. In general, we try to keep our code base consistent, so we only use one framework across all the BFFs. So we use like React everywhere, we use like Node.js and Express.js everywhere. So this allows us to reuse a lot of libraries, both client-side and server-side. This also allowed us to build the design system in React. So we are using the same components to render the UI across every front-end application. And because BFFs are really small, you can assign like a clear owner to that. So each BFF has one team that owns it. And whenever you have a question or whenever you have a PR, you want to do something and you don't own that BFF, you know which team you should contact and ask, for example, for PR review. So yeah, as I mentioned, the code share and reuse is quite important for us. So on the client side, we share, for example, all the styles, all the fonts, all the images via the design system, but also we share like smaller React components like buttons, inputs. We also share much bigger, we call them like organisms, or you can think of like a standalone applications like header, login dialog, footer. So all of those components are built once, they are part of the design system, and then they are simply reused in all others. And of course, we reuse type definition. So we try to expose types from each library so we can use them in the BFFs as well. On the server side, we also share a lot. Like you can think of all the middleware chains. So we process the incoming request in the similar manner in all the BFFs. We have shared API clients, so you make the request to downstream APIs in the same manner across all the BFFs. We have our own library to do server-side rendering of our React applications. Of course, for all the low-level infrastructural things like gathering metrics, doing logging, doing tracing, we also have shared libraries. And yes, we do share quite some types for the server-side code as well. So when it comes to testing, we try to adopt this testing trophy approach, which is described by Ken C. Dodds. So if you follow this approach, you focus, it encourages you actually to write more integration level tests rather than trying to achieve 100% code coverage with unit tests. And then you also rely on the static analysis a lot, and you try to write as less as possible end-to-end tests. So in our case, we only write end-to-end tests for business critical flows. So you can think about like the logging flow or the flow to place a net. So those are business critical, we keep end-to-end tests. But for other not so critical flows, we rely more on metrics. So we monitor important business metrics after, let's say, we deploy a certain feature. And if metric goes out of range, you can easily roll back the change you did. I will explain later what tooling do we have in place for that. So, but basically, at the moment, our developers are not afraid of deploying new features because they know that they can revert the change quite quickly and it won't impact a lot of users. But this allows us also to move much faster because we more rely on integration tests, so you can refactor quite a big chunk of your code without touching a lot of tests, but it still gives you very high level of confidence that the feature works as expected. And next to that, because we are using a lot of experiments, it's almost impossible to test all the possible combinations, like experiment A, this experiment is in this group and this experiment, because there is an intersection and you need to multiply amount of experiments by amount of groups. So it's almost never possible to test what's the actual code running on production. So that's why we prefer to rely more on metrics for that. So the way how we build and deploy, we also share a lot of, basically, all our BFFs, they use the shared build process. So we have the same Webpack config, Babel config, ESLint, and TS config across all the BFFs, across all the front-end applications. So at the end, they produce the artifacts in a similar shape. You can think like all our front-end applications, because they're built with the same Webpack, they have the same vendor bundle at the end, yeah, because they're all using the same version of React, more or less. They're using the same version of third-party libraries. We try to achieve that. We also have the multi-stage Docker build, and the unit and integration tests are part of this multi-stage build. We try to automate dependency updates with Renovate because, as I said, we have 25 Web BFFs. We also have the same amount of App BFFs. And whenever we release a new version of internal library, we want this version to be propagated as fast as possible to all the BFFs, so to keep them up to date. Also, for each PR that you create, we automatically run build, and we allow to merge PRs only when the build is green, so we're not allowed to break the master. Next to that, we introduce the security scans by Sneak.io. So this tool analyzes your dependencies on external libraries like React, Redux, whatsoever. And whenever there is a new version that fixes a security vulnerability, it will automatically create a PR to update your project with this version. And next to that, we also have some quality checks with SonarQube. So we want to ensure that whenever you push a new code, you at least meet our quality gates. So for example, you don't reduce the code coverage. And the way how we deploy, what gives us confidence that whatever feature we deploy to production, how we it won't break the whole website down. So we wrap everything that we create. We wrap either in a feature switch or A/B switch. So this allows you to enable the new code only for a very limited subset of users, and then gradually increase the exposure. And then you can measure how your new feature impacts like the most important business metrics. And if you think that something is wrong, you can easily turn the switch off, and then the code won't be executed. You can also do a canary release. So if your feature is very low level, think about something that, for example, you optimize the performance of your server side. In this case, you can do a canary release. You can compare the canary version versus the normal version, and if you see the positive impact, you can continue deploying it. Next to that, we have one-click production rollback. So imagine you did not use feature switch, you did not use canary release, you release something to production and you notice that something goes wrong. There is one button that will automatically roll back the current version and release the previous one. And what's important for us, again, with the amount of BFFs that we run on production and the amount of dependencies, you know that the front-end applications are very famous that they have hundreds of dependencies, even to build a very small page. So we built an overview of all dependencies of all the third-party packages and internal packages, NPM packages that are currently used on production. So we can, for example, see, okay, what version of React we are running on all the 25 BFFs. And if some BFF is maybe lagging behind, we can do certain action, for example, upgrade the React and release it to production. So when it comes to scale and performance, the small size of the BFF also helps us here a lot. Because as I mentioned, each front-end application uses only its own backend for front-end. And because this backend for front-end is small, you can easily scale by just increasing the number of instances. While we're now working on other strategies because we are now moving to the public cloud, so probably increasing amount of instances in the public cloud is not the cheapest approach, but now we are in private cloud, so it works. We're also looking into improving our Node.js performance. Well, you probably know that the biggest impact on the Node.js performance is the CPU. So if you have a CPU-intensive operation that blocks the event loop, you will have, it will impact on all the incoming connections. And one of the operations that is probably the most CPU-heavy at the moment is server-side rendering. So we try to render only the user-critical content, the app shell, or only do SSR for bots, because still Google prefer if you give him away the rendered HTML. So we still need to do SSR for bots. To help here, we try to experiment with offloading the SSR to a separate thread. Now with the worker threads feature, you can do it much easily. As I told that our BFFs, they make a lot of calls to downstream APIs. So the way how you can optimize performance if you can run those APIs in parallel, and that's what we try to do. And next to that, the BFF doesn't make a call directly to the instance of the API. We always do it via the load balancer, and load balancer is quite smart. So he's able to choose the API instance of the API that runs as close as possible to the BFF instance, and the API instance that has the lowest latency. And next to that, on the client side, we use the CDN, which is shared for all the BFFs. And because all the BFFs are using the same Webpack config, the artifacts are the same. So, for example, the BFF A has the vendor bundle with React and has, let's say, a set of fonts and images that is used for common components. It is deployed to CDN, but then the BFF B also has the same build. So images, fonts, vendor bundle is again the same. It is also uploaded to the same CDN. So the end user only downloads those resources once, even he's, during his journey, he's jumping through the pages that are rendered by different BFFs, but most of the client-side resources stays the same, so the browser will download them only once. So alerting and monitoring is very important for us because, yeah, as I mentioned, we prefer not to cover everything. Well, for us, it's not feasible to cover everything with tests, so we rely a lot on alerting and monitoring. For the client side, we mostly use Sentry to collect our error logs. Well, to be honest, I'm not a big fan of Sentry, so guys, if you can propose a better tooling for that, yeah, please advise in the comments. We also do regular performance tests, and we monitor real user performance by speed curves, which helps us to optimize the performance. So, for example, from the previous talk, you know how important is content layout shift, and we have a graph that helps us to constantly monitor it, and whenever it goes too high, we act on that. On the server, we even collect mod data. We collect all the access error logs in Kibana. We gather a lot of metrics in Grafana. Maybe the most important for us to track how healthy our BFFs are is Node.js event loop lag, the memory consumption of the Node.js, how garbage collector works, but also the response statuses and response latencies. And because our system is distributed, so each BFF talks to multiple downstream APIs, and then those APIs talk to some backend services. Tracing is important to get, the complete picture, to understand, okay, what services were involved in order to serve one specific user request. So for that, we use Jagger. So after in this journey for 3 years, what are the pros and cons of this approach? So the biggest pros that I see is, first of all, we have huge improvement of time to market for product features, because at the moment, each team can deploy independently features to production. We have much smaller, more isolated, and easily maintainable code bases that helps a developer to be confident that whatever feature he or she builds, you introduce much less regression on other parts of the system. And this is a very good field for scalable organization like Marktplaats is, because we have decoupled autonomous teams, so they prefer to own everything that they run on production, and they prefer to deploy all the services on their own pace. They don't want to be blocked by someone external, so this helps a lot. And for the migration project, it also allows us to update and rewrite parts of the front end in a more incremental fashion. And that still helps us, because if you want to rewrite a certain BFF, you can do it in isolation without touching anything else. But of course, it comes with a price, yeah? Maybe for the end user, we still see that because each BFF has its own set of dependencies, it impacts the user because it might download more bytes that we would like him to download. So if you have one single application, in this case, we can do much better optimizations on what user will download. The team autonomy, this is great, but if you keep it like this, and if you don't keep eye on that, it can lead to platform fragmentation and inconsistent in your code base and APIs. And that's what we observe at the moment, and we try to act on that, trying by guiding all the teams, trying to make sure that everyone is following the best practices, everyone is following the same approaches whenever solving similar challenges. And of course, it's an extra effort to keep all front ends up to date. So I mentioned you that we use Renovate for that it helps us. We also use Sneak to keep our dependencies up to date. So you need extra tooling in order to make it work for you. And sometimes our CI/CD pipeline becomes a bottleneck. Yeah, as I mentioned, there we have multiple BFFs. Each BFF can have multiple deploys per day, but also we do a build for every PR. So at the end, we have a lot of jobs running in our Jenkins, and sometimes you have complaint from our DevOps team that, Jenkins is overloaded. So how do we make decision to make sure that, we still keep our platform consistent? So first of all, we have front-end chapter. So the front-end chapter is the place where all the front-end developers gather together and collaborate. It also encourages the knowledge sharing across everyone, and it also makes sure that we can align on how we build features, what we build. We try to document every important decision that we make in this front-end chapter. We try to make an ADR, architecture decision record, out of it, so we can keep it, and we can come back and refresh in our minds, okay, what we have agreed on and why we should do this way rather than the other way. So this is important, especially if you need to onboard new people, or whenever developers are moving between teams. It's very important because ADRs allows you to keep the knowledge. And then next to that, we have a tech radar. So it's a list of technologies and tools that we allow to use on production, that we are experimenting, but maybe the most important, that we don't allow to use. And a bit of like what are our plans for future. So as I mentioned in the beginning, we only have at the moment infrastructure and build time composition, and we want to adopt the runtime composition. And for that, we decided to go with Webpack Module Federation. So for us, it's very important to make it work nicely with React SSR, because as I mentioned, we need to do server-side rendering for multiple reasons. So that's why we want to build a proof of concept for one application, collect metric, learn, pinpoint what are the recent obstacles, and then propagate this approach and maybe adopt it more widely. And at the end, what we want to achieve, we want to make sure that single React application is the minimal delivery artifact, instead of what we have at the moment. It's a complete page which can have multiple React applications running on it. And that will also allow us to update the shared features. Think about header, footer with a single deploy. So at the moment, because header and footers are incorporated during the build time, if you do a change to a footer, you need to redeploy all the services that are using it. If it's a separate deployable, you can only deploy it in isolation. Then every frontend will get the updated version of the header automatically on production. So at the end, there are a few useful links. So if you're interested in this micro frontend or backend for frontend architecture approaches, yeah, please follow them. And thank you for your time. I think we still have a few minutes for questions. If not,
yeah, we can do a couple really quickly. So the first one's coming from Gary. He's asked, when moving from one micro frontend to another, does it result in a full page refresh, or is it possible to maintain a client-side transition?
So at the moment, it is a full page refresh, but with the client-side, with the runtime composition, it would be able to maintain a client-side transition. So we're experimenting with that.
Okay. The next one is from Alexei. He's asked, do you have React in every micro frontend app, or do you have a common version for the whole app?
So at the moment, our approach is to have one React version for the whole app. So basically, each micro frontend app doesn't ship its own version of React. That's our approach.
Nice. Okay. And then there's just two more. And so this one is asked, what is the granularity of your BFF micro frontends? How big are they? Could you get a few concrete examples of them?
Yeah. So at the moment, the smallest piece that we are able to build, or basically that we are using on production, is a single page. So you can think, for example, like the home page, or the form, the place you add form. So something like that. We are experimenting with the smaller things, but these are under experiment still.
Okay, well, it'll be good to hear in the future, I'm sure. And then the last one is also from Gary. Roughly how many front-end engineers work on these? We started to look at micro front-ends, but found having a small team added to too much overload.
Yeah, so in general, I think we have roughly like 15 front-end developers, and they are split between like 4 different teams. So each team has like 3-4 front-end engineers. But in general, it's like the 15.
All right, good. So maybe something to sync on also offline. So thank you so much, Eugene. I know it's time for our break, so I won't keep you or the audience waiting. Thanks so much.